Okay, let's give you guys some practice. So here you've got a fish tank, and the water is currently in the form of a circle, given by this formula here. So currently it's half of a circle, exactly half of a circle. When the water level settles, it will probably settle somewhere around here. So find the height of the water level when it settles. Okay, so press pause and have a go. Okay, so to do this, when the water settles, let's say it settles around here, the area of this rectangle will be the same as the area of the semicircle. So to find out the height of the water when it settles, what you should do is, well, let's rearrange this equation first. So y squared equals 1 minus x squared, and then when you square root it, you will get two versions, one positive and one negative. So it will look like this. The positive version would be this. The negative version would be this. Let's forget about the negative version because we're only concerned about the positive. So really, it's your job to find out the area of this whole thing here. So get the whole area, which is given by this -1 to 1 root 1 minus x squared dx. So this block here will then give you the area of the whole semicircle, and then divided by the width of the fish tank, which will be 2, because from here to here is 1, and from here to here is 1. So you divide it by 2. So this here would then give you your average height for y, which is where the water will settle. But rather than doing this, it's more efficient to just do it from 0 to 1. So rather than doing this, just do it from 0 to 1, and then divide it by the width. The width happens to be 1, so it's going to be like this, which is just there. So when the water settles, it will settle somewhere around here. The height of this thing here is given by this from 0 to 1, and then you divide it by the width. The width happens to be 1, so you divide it by 1. So it's given by this. Hang on. So the water level when it settles will be given by this thing here. So now it's just a matter of evaluating this. So create your eyes should zoom into this bit. Create your triangle in such a way that this will be true. Well, if you make the hypotenuse to be 1 and the opposite to be x, then the adjacent will have no choice but to be 1 minus x squared. So now looking at this triangle, we need to extract this dx. So looking at the triangle, let's use sine. So sine theta equals opposite over hypotenuse. Opposite over hypotenuse. So from here, differentiate. That will then give you this. So dx is given by this. We can now put this into the dx. But then we need to extract this from the diagram. Well, looking at the diagram, cosine theta equals adjacent over hypotenuse equals adjacent over hypotenuse. So now we can put this into here, and we can put this into here. That will then give us this thing. So this thing here is this, and then this thing here is given by this. So now tidy this up. That will then give us this. Remember, this is in terms of theta. Our x is in terms of x equals 0 to x equals 1. We will need to convert all the thetas back into the x, and then we can make use of x equals 1, x equals 0, x equals 1. So that will then take us to here. So now it's just a matter of integrating cos squared. So to integrate cos squared, we would make use of this. By the way, you can make use of the reduction formula. It's more efficient. The reduction formula will probably take you straight to here. Well, anyway, to integrate this, make use of this. Put this into here. That will then give us this thing. Now integrate. So when you integrate to half, it will be theta over 2. Integrate this, it will then be this. But we want to translate everything. We can't really translate a double angle. So let's make use of this. Let's make use of this. So making use of this, we would put this into here. That will then give us this thing here, and then the 2 and the 4 will simplify, and it will then give us this, and then now all the answer is in terms of theta, but we don't want the answer in terms of theta. We want it in terms of x. So going back to the diagram from above, we want to extract theta. Well, if you look at this, sine theta equals x. So theta equals inverse sine of x. So we can put this into here. That will then give us this. And then sine theta, well, sine theta is given by x. So we can put this into here. Cos theta, this is cos here. Cos theta equals that square root thing over the hypotenuse, 1. So we can now put this into cos. That will then give us this thing here. And then now from x equals 0 to x equals 1, we can just jump to 0 to 1 because we are now in terms of x rather than theta. So now put this into here. That will then give us this. Put this into here, put this into here. This thing here will be 0, so making the whole thing 0. And then when you put 0 into here, it will be 0. Put this 0 into here, the whole thing will be 0. So we can forget about 0. Well, overall, your answer will be pi over 2. So when the water settles, so going back to the start, so when the water settles, it will settle at a height of pi over 4. So when the water settles, it will settle at pi over 4. I don't know where, somewhere around here. Pi over 4. Okay?